Okay, everybody, let's talk about our last type of boundary out of the three main boundaries for plate tectonics, and this is the transform, otherwise known as shear fault boundary type. Here's your notes for transform boundaries. Transform or shear means that plates are sliding. They slide and move sideways alongside one another. They create fault lines. They create earthquakes. They're very common throughout the world. The most famous example is probably the San Andreas Fault, which many of you have probably heard about, and you've probably heard about in class. The transform boundaries occur throughout mid-ocean ridge systems as well, which is why they are so common throughout the world. So here is the San Andreas Fault. The picture on the left is how you would see it from very high up. I've heard that you can actually see it with a good telephoto lens from outer space. And then the picture on the right here is kind of the common diagram simplified, where you can see the North American plate on the right or on the east side, and the Pacific plate, which is primarily ocean, but there's a sliver of the Pacific plate which is actually continental crust, and that is scraping alongside the North American plate. So tectonically speaking, Los Angeles is not on the same continent or tectonic plate as us. However, San Francisco is on the same tectonic plate as Minneapolis. If we look at the plate tectonics of this region, showing you the Baja of California down into Mexico, there's a ridge system that you can see in the lower right-hand corner, and there is definitely a small ridge system there called the East Pacific Rise, which has transform faults through it. And then there's the huge transform fault of the San Andreas, which extends all the way up to what is called the Mendocino Fracture Zone. And then north of that, you have the large Juan de Fuca Ridge, and that is the ridge system that actually supplies crust that is sent into the subduction zone off the coast of Oregon, Washington area. So this large transform fault is significant. It really is that connection between multiple plates and allows the Pacific plate to graze or slide northwestward across the North American plate. Otherwise, this movement wouldn't be able to occur. I don't know about you, but that's some pretty cool stuff to see how all of that actually works. Complicated, but cool. The last thing mentioned on the first slide of notes was how transform faults actually are a significant part of mid-ocean ridge systems. Mid-ocean ridge systems do not actually uh, diverge all along one single line for thousands of miles. They're actually a system of alternating ridge, ridge, transform, and that's how this thing works. Otherwise, this broken backbone of divergence and interlocking pieces of crust would not actually be able to diverge. Here's your notes one last time. Transform boundaries. Plates slide and move along sideways next to each other. They create significant fault lines. They create earthquakes. They're very common throughout the world. The most famous is the San Andreas Fault, and transform boundaries occur throughout all mid-ocean ridge systems. A few graphics, particularly in the beginning of this video, the graphics that were in motion were taken from the Theory of Plate Tectonics, TASA Graphics Arts Incorporated, written by Edward J. Tarbuck and Frederick K. Lutkins, Illinois Central College, illustrated by Dennis Tassa.